Hi there. So we're going to look at another type of problem using quadratics. And to do that, we're going to remember back to our problem that we did at the very beginning of the unit when we started talking about what we should charge for dance tickets so that we can get the most revenue. Okay? So it's going to be an economics problem that we're looking at today. And I just want to remind you of what we started with. We said Castlebrook Secondary School Student Activity Council is planning to put on a dance. Dances are fun, but Ms. Semler has asked the students to ensure that they maximize the income from dance tickets. So the council got together, created a survey for students, and the results said the most students that'll come will be 700, and this would happen if they charged $3 per ticket. Okay? Then they said every time they increase the price by 1, they will lose 45 students. And then the question was, what should they charge in order to maximize income? Okay? So first I want to create an equation with you guys. Okay? Now creating the equation is tricky, but we're going to work on it. So we know that the revenue is going to be the number of tickets sold times the cost per ticket. Right? So if they sell 2 tickets at $5 each, their revenue is $10, right? 2 times 5. Okay? So we need an x variable. Okay? Well, for x to be the cost, that's no good because it's not the cost that's changing, right? What's changing is the increase in price, right? So what we're going to say is we're going to say let x represent the number of $1 increases in price. Okay? So that means that our revenue equation is, well, the cost per ticket starts at $3, but increases by X dollars, right? So X is the number of $1 increases. So if it increases once, then this is going to be 4, 3 plus 1. If it increases twice, then this is going to be 5, 3 plus 2, right? And then the number of tickets sold, well, they're going to start at selling 700 tickets, right? Because that's the most that would come. But then they're going to lose 45 people for every increase. So I'm going to subtract 45x. Okay? All right. So this is how we create an equation. Okay? So that's not the main focus of what we wanted to do today. I want to analyze the equation. But I just wanted you to see how the equation is made. Okay? So that's our equation. And now the question says to represent it in standard form. Okay, so this is definitely not standard form. So what we have to do is we have to expand. Okay, so we'll expand. 3 times 700 is 2,100. 3 times negative 45 is negative 135x plus 700x minus 45x squared. Okay, so now we collect like terms. So that's this and this. So that'll be plus 565x minus 45x squared. Okay, so that means that the standard form, remember standard form has to be ax squared plus bx plus c. So that'll be negative 45x squared plus 565x plus 2,100. Okay, so there's our standard form equation. Okay, so you see how those skills of expanding we're using right now, right? So I created an equation and now I want to represent it in a form that everybody will understand, and there it is. Okay, so that's our equation. So I'm just going to paste the equation here. So again, I want us to write this equation all the time. Okay, so the maximum revenue, obviously we're looking for the maximum of this parabola. Okay, so this is in standard form, right? But I also want you to remember that we have something that looks like factored form. Okay, so I'm going to rewrite that one as well. So the revenue is, we said x plus, we said 3 plus x, and then 700 minus 45x. Okay? So we've got part 1 and part 2. Okay, same equation, just represented different ways. So to find the maximum, remember we can do this two ways, right? So I'm going to use this method first, okay? And remember, if we have it in what looks like factored form, now this isn't perfectly factored form because we can factor here, but it looks like factored form, we can find the zeros and average them out, right? So what we're going to do is we're going to find the two zeros. So this tells us that x could be -3. And this one here tells us that x could be, once you solve it, you move the 700 over, divide by 45, you get x is about 15.56. Okay? So there's my two zeros. Now remember, the reason why we're doing that is because the vertex will happen in between the two zeros, right? So I have 0, 0. The vertex will happen right there, right, in between the two zeros. Okay? So that means what I have to do is average these out. Okay? So for the vertex, the x-coordinate is -3 plus 15.56 divided by 2, which is 6.28. Okay? Okay, now I want to get back to this question and says, what's the maximum revenue that they can attain? Okay, so the maximum revenue that they can attain, this isn't it. This is the x value, right? So the revenue is actually, we can plug it into the equation, right? So we'll plug it into either one of these, it doesn't matter. So -45x squared plus 565x plus 2100. Okay? So you need to work that out, and you'll get an answer that looks like $3,873.47. Okay? So this is the maximum revenue that they can hope for. Okay? Now, I want to remind you that this is factored form, sort of, and this is standard form, right? And we figured out how to find the vertex from standard form. Okay? So using this, okay, I want to remind you that we can skip all this. Okay? If we have standard form, we can skip all that averaging the zeros. Okay? So we can say use the standard form. So 565x plus 2100, right? And we'll remember that for the vertex, x is equal to -b over 2a. Okay? And when you work that out, you actually get 6.28. Okay? So notice that this answer is exactly the same as that answer. Okay? So you can get your x value in a variety of different ways. Okay? You can either find the zeros, average them out, or if you have standard forms, just use -b over 2a, and you'll get your answer. Okay? And so again, after this, you have to find your revenue. Okay? So these are just two different ways that we can do this question. Okay? All right. So now the question is, what cost is going to yield the maximum revenue? Okay, so we know that they're looking for a revenue. They're looking to make $3,873. Okay, so the question is, what's the cost of the ticket that is going to get the revenue? Okay, well, I want you to look back here, and we said that X is going to represent the number of $1 increases. Okay, well, we found out that X was $6.28. So the original cost of the ticket was $3, right? And we're going to add on $6.28. So 3 was the original cost, right? And then the increases to maximize revenue is $6.28. So that means the cost should be 3 plus $6.28, which is $9.28. Okay, so that means that we should be charging $9.28 per ticket instead of $3 in order to maximize our revenue. Okay, and then the last question, how many students are going to come to the dance? Well, I also want you to remember that we said that we're going to start off with 700 students. Okay, so we're going to start with 700 students, but we're going to lose 45 for each increase. Okay, so we're going to start with 700, but we're going to lose 45 per increase while we're doing 6.28 increases. Right? So that means that we're going to end up with 417 students. I'm rounding to the nearest whole number because it's the number of students, right? Okay, so see how we've very quickly analyzed the entire problem, right? We were able to make an equation, okay, and then use that equation to find the maximum, to find the number of students, and to find the cost, okay? So what we found out was that we need to charge $9.28 per ticket, right? We found out that 417 students should come, and we found out that our revenue will be $3,873.47. So $3,873.47. Okay, so this is the situation that we need in order to maximize profit. So now you see how quadratics are very important to the business world, because they actually run these tests, they run the studies, they find out what they need to charge, how many customers they're going to expect, so it tells them what kind of inventory they need, and they find out what maximum revenue they should expect so that the stockholders know whether to buy, sell, whether it's going to increase, decrease. Okay, so there's our example for today, and I will see you folks in class tomorrow.